In this lecture, I will explain transistor saturation. The transistor is said to be saturated when the collector current IC is larger than or equal to the maximum collector current for the particular design. Let's say the maximum collector current is IC max, and we have the saturation condition when the collector current is greater than or equal to IC max, and in this condition the collector current is represented by IC sat, representing the collector current in saturation condition. We try to avoid the saturation conditions because in saturation region the collector base junction is forward biased and there is distortion in the amplified signal. We are trying to amplify the weak input signal using transistor, and for this purpose transistor must operate in the active region. Transistor must operate in the active region, and in active region the collector base junction is reverse biased and the emitter base junction is forward biased. But in saturation region the collector base junction will forward bias and the emitter base junction is already forward bias, so the resistance offered is nearly equal to 0. That we will try to see by the help of this output characteristics. This is the output characteristics of common emitter transistor, and we already know this region is the active region, and the region on the left hand side of this green line is saturation region, and the region below the base current IB equal to 0 is cutoff region. And as collector current is larger than or equal to the maximum collector current, the transistor will operate in the saturation region. This means the operating point or the Q point is in the saturation region like this. And if we consider the approximate curves, then it will look something like this, and you can clearly see the collector current IC is relatively high and VCE is 0. The collector current IC, that is IC sat, is relatively high and VCE is equal to 0. Now we will try to find out the resistance, and for this I will use the Ohm's law. We know IC sat multiplied with RCE is equal to VCE. We want to find out resistance RCE, so RCE is equal to 0 volts because VCE is equal to 0 volts by IC sat. So simply the resistance is equal to 0 ohms. This means there is no resistance between the collector and emitter terminals, and we can short circuit the two terminals. Now we know what actually happens when transistor operates in the saturation region. The relatively high collector current is there and VCE is equal to 0 volts, and because of this collector and emitter terminals are short circuited. Now we can easily find out the saturation condition for the fixed bias configuration. Saturation condition for the fixed bias configuration. First we will draw the circuit of fixed bias configuration, then we will find out the collector current in saturation region, and as the collector current IC is equal to the maximum collector current IC max, the transistor is operating in the saturation region and the collector emitter terminals are short circuited. Now we will calculate the value of IC set by applying KVL in the output loop. We have VCC minus ICRC. IC is IC set equal to 0, and from this equation you can see IC set is equal to VCC divided by resistance RC. So this is the condition for saturation in case of fixed bias configuration. The next thing is condition for saturation in case of emitter bias configuration. In case of emitter bias configuration, and again we will do the same thing. The collector current is equal to the maximum collector current. So we have IC set, and we will draw the circuit of emitter bias configuration. In case of emitter bias configuration, we have emitter resistance Re, and the transistor is operating in saturation region. So the collector emitter terminals are short circuited, and when we apply KVL in the output loop, we have the equation VCC minus IC set RC minus IE RE equal to 0, and we know IE is nearly equal to IC, or we can say IE is nearly equal to IC set. We have VCC minus IC set inside the bracket RC plus RE equal to 0, and from this equation IC set is equal to VCC divided by resistance RC plus resistance RE. So this is what you need to do in emitter bias configuration. Now there is one homework problem. In this homework problem, you need to find out the condition for saturation, that is IC set, for the collector feedback bias, for the collector feedback bias, and for the voltage divider bias, for voltage divider bias. Once you have your answers, post them in comment section. I will end this lecture here. See you in the next one.